Okay. Guys, if you do, please stop me anytime so I can repeat whatever you need. Okay, so as I said, this is chapter 15, lesson 2. Okay, so guys, you will have 2 study sheets, inshallah, by Saturday or by today, inshallah, if I could. There will be 2 study sheets, one for chapter 15, lesson 1, and the second one will be for chapter 15, lesson 2. Okay? Okay? You can find the worksheet. Yes, you can find the worksheet with the model answers on your SMS /library. Okay, you'll find it in my library. Guys, I want to make sure you understand what's going to happen, inshallah, next. If I want you guys to have a worksheet so we can do it together during the session, so it's an assignment, it will be found in the assignment section. But if this worksheet is done already, we already did it, and you need the answers for it. So if you want to, you know, like redo it or something, you will find it in the teacher's library. Any summaries, any study sheets will be found in the teacher's library. Any announcement that I need you guys to know will be found in the teacher's library. So you will only find in the assignments the worksheets that we will do together, inshallah, in the future. Okay? Like if I needed you guys to print something or to have your worksheets with you for the next session, it will be found in the assignments, because some of you guys said that they couldn't find the assignment last session, so because they searched on the teacher's library. Okay, do you get this point?
Yes, miss.
I hope you do. Okay, so as we said, we learned about the wave properties, and the first property was amplitude. Okay, and amplitude could be said as how high the wave will be. So we have number 1. Guys, please get your notebooks ready with you. Yeah, make sure you have your notebooks with you so you can write these notes with me. Okay, I will give you a minute for you guys to get your notebooks. If you don't have your notebooks right now, you can screenshot, of course, when we finish, and write it later in the notebook. Okay, so as I said, the first wave, I hope you guys can now see well. You don't have any problems with the smart school. I'm sorry, with the smart board. Okay, so as I said, amplitude is how high the wave is. So if we have a wave right now, we call this the rest position. Okay, and also shows us the direction of the wave. Okay, so if I have a wave here, the length or the distance in here is called amplitude. It's called amplitude. So it could be the distance from the highest point of a wave, because of course this is the crest, the highest point, okay, and we have the lowest point in here. We call it, guys, when I say we call it and I stop talking, that means you should talk. Okay? Yes.
Trough.
Yes. Thank you so much. So the distance from the rest position to the highest point of a wave is called amplitude. Could be the distance from the rest position to the lowest point is also amplitude. Okay, guys? Okay?
Okay.
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 So can someone tell me how many waves do we have in this graph? Can you tell me how many waves do we have? Do we have 2 waves, 3 waves, 4 waves? How many waves?
2.
2, yes, because a wave must contain 1 crest and 1 trough. So here we have 1 and 2. We have here also crest and another trough. We have here another crest, and here we have another trough. Okay, so the amplitude again, guys, is how high the crest will be, or we can say the distance from the rest position to the highest point, and the distance from the rest position to the lowest point. What do we call this wave? Is this a transverse wave or a longitudinal wave? Guys, can you hear me? Is this a transverse wave or a longitudinal wave? Yes, Ruqayya.
Transverse.
Yes, you raised your hand. So again, Ruqayya, is this a transverse wave or a longitudinal wave? Okay, can someone else answer?
Transverse.
I can't hear you, Ruqayya.
Transverse.
Yes, thank you so much. It's a transverse wave. Thank you so much. Transverse wave, again, is the wave in which the particles of the matter move in a right angle. A right angle, guys. If you look closely in here, you'll find that we have right angle in here, okay? Which we call perpendicular. Moves in a right angle to that wave direction, or we can say perpendicular to the wave direction. Okay? Okay? Okay. So this is the amplitude, how we can find out the amplitude in the transverse wave. What about the longitudinal wave, the one with compressions and rarefaction, or we can say the one where the particles of the matter move in a parallel to the wave direction, which has, you know, parts of it where the, let me change the color back. Okay. Okay. Where we have parts where the particles are far from each other, and other parts where the particles are closer to each other, which we call compressions, and others where it's far from each other. Okay? So these parts are called rarefactions or rarefactions. And where the particles are closer to each other is called compressions. Okay? You can remember these two words by compress. Compress means to push things or to pressure things. So that's why the particles are closer to each other in this point. That's why we call them compressions. Okay? And where the particles are far from each other, as you can see in this point here, they are far from each other, where we call rarefactions. Okay? I believe now, guys, by now you understand these things. Okay?
Yes.
Okay. How can I measure the amplitude in this point? How can I find it out? Okay. We all know that sound waves are longitudinal wave, which means they will be moving in this way, in the compression shape, or the compression and rarefaction shape. Okay. How can I measure the amplitude in here? Do you guys know how can I measure the amplitude in this point? We talked about this yesterday, if you remember, Ian. Let me show it to you again. Can someone tell me? And أصلا did we learn about it in this position? Yes, Karim.
The space between the rest position and the crest, or the rest position and the trough.
Thank you. Yes, yes, that's in the longitudinal, in the transverse wave. I was talking about the longitudinal wave. I mean, if I wanted to measure the amplitude of a sound wave, if I wanted to measure the amplitude of a sound wave, a sound wave is not a transverse wave. Yani I will not draw it like this. It's supposed to be this one, right? The one on the right. It will make it so difficult for us to measure the amplitude, the wavelength, and so on. So the scientists, they decided to draw the sound waves, which are transverse wave, longitudinal wave. They decided to draw them in a transverse shape to make it easy for us to find out the amplitude and the wavelengths and so on. Do you guys get this point? Yani, they found it so hard to measure the amplitude when we have a longitudinal wave, or the shape of the longitudinal wave. Okay, so they decided that we can draw the longitudinal wave in the shape of a transverse wave to make it easy for us to calculate or find the amplitude and so on. Do you get what I'm saying?
Yes.
Okay, guys. Okay, alhamdulillah. Guys, anyone doesn't understand what I'm saying? I can repeat everything all over again. Anyone? So that means that all of you guys understand, right? That then when we move to the worksheet and the questions, you will be understanding, right?
Yes.
Okay, I hope we'll see that. So again, the amplitude, as we said, guys, is the highest, the distance from the highest point of a wave to the rest position, or we can say the distance from the lowest point of the wave to the rest position. Okay, guys? Okay? Okay. Now we'll move to the second wave property, which is the wavelength. The wavelength. And the wavelength, guys, is also a distance, okay, from one point of a wave to the same point on the second wave or the next wave. So it could be the distance from one crest to the next, or one trough to the next. And now we're talking about the transverse wave, okay? Let me share the whiteboard again. Okay, so guys, did you write this? I will wipe this out. So do you need more time to write down these notes?
No.
Okay, I will erase them now. So both amplitude and wavelengths are both distance, okay? But of course there is difference between them. Okay, so number 2, we have wave length. Okay, we have 2 waves in here. We have 2 ways to calculate them. We have in the transverse wave and the longitudinal wave. Okay? Okay. We all know the shape of the transverse wave. We have crest, trough, crest, and trough. Okay, and in the longitudinal, we have parts where the particles are closer to each other and parts where the particles are far from each other. And again, okay, let me draw it a little bit better for you guys. It's so hard, by the way, to draw a longitudinal wave. You think it's so easy, but actually it's so hard to draw it because you need them to be the same size and the same tonus and everything, but it's so hard to do this in the smart board. Okay, so if you can see here, I hope you can see it, see the difference. So we have parts where the particles are closer to each other, which we call the part of a longitudinal wave where the particles are closer to each other. What do we call this part?
Compressions.
Thank you. Yes, compressions. Yes. And the part where the particles are far from each other?
Rarefaction.
Rarefaction. Thank you so much, guys. So those are called compressions, and those are called rarefaction or rarefactions. Of course, we have here crest and we have trough. The wavelength in the transverse wave is the distance, as we said, from one point of a wave to the same point in the next wave. So it could be the distance from one crest to the next crest in the next wave. It could be again the distance from one crest to another in the next wave. It must be in the second wave or the next wave, yeah, not the second wave, the next wave out of, okay? Or it could be the distance from one trough to another in the next wave. We call this trough, okay? Should it be just like that? No. The definition of wavelength said that it's the distance from one point on the wave to the same point in the next wave. So it could be the distance. And what I was saying is that the wavelength is the distance from one point on a wave to the next, the same point on the next wave. We can say it's the distance from one crest to another crest on the next wave, or the distance from one trough to the trough also, but on the next wave. But what I was saying, guys, is that you will learn this year that wavelengths is not only crest and trough. It's the distance from one point to the same point on the next wave. So it could be, for example, the distance from this point, can you see it? To the same point Can you see the distance in here?
Yes.
Yes, this could be wave length, right? It could be this point. It could be, what happened? Okay. It could be this point, as I said. this point in here. To the same one on the next wave. Is it this one? This one? Is this the same point? Guys, is this the same point?
ما في السكرين معمول لها فريز.
Your screen is freeze?
لا خلاص اتحرك.
Frozen.
اتحرك.
Again, guys. So it's again the distance from one point on a wave on a wave. Can you see this point? The yellow one?
Yes.
Okay. So do you think this is the next point or the same point? The one with the circle. Do you think this is where I should put my point in here? Is this wavelength? Do you think
لا.
Yes, no, this is wrong. This is not a wave length because it should be the same point. The same point on the next wave. So to determine this, look at the wave. It started from here and the high point ended here, right? We can say the crest ended at this point. So we'll look at the next wave. See where does it start? It starts from here and it ends here. So this is the same point. So this is the wavelength now. Do you get it? Do you get this? Do you get it now?
Yes.
Yes. So it should be the same point. Okay, this is in the longitudinal wave. Now let's move to, I'm sorry, this is in the transverse wave. Let's move to the longitudinal wave. We have compressions and rarefactions. They should be the same point. So, for example, if I started from the middle of a crest, okay, I'm sorry, of a compression, it should be the middle of the next compression. If I started from the beginning of one rarefaction, it should be the beginning of the next one. Okay, guys? It should be the same point. So if it's a beginning of a rarefaction, like in here, in this one, it should be the same beginning of the next rarefaction. If it's the middle of one compression, it should be the middle of the next one. Do you get this point, guys?
Yeah.
Yes, you will need to know this distance, inshallah, when we learn about frequency. Okay?
Okay.
Any questions about this part?
No.
Okay. So here, guys, he's showing you the wavelengths in the longitudinal. Here, he started from the beginning of one compression. So it will be the distance to the beginning of the next compression. Okay? Okay. Now we'll talk about frequency. We have less than 5 minutes. Frequency is very important because it determines how high or low the sound will be or the wave will be. Okay? So if you're talking about the sound wave, for example, how high, remember, like we talked about this last year, which is the pitch, okay? Okay? How high or low a sound is, remember? If it's a really high sound like the serene اللي هي السرينة بتاعت الإسعاف, it's so high sound, or is it deep sound like men's sound? They are so deep, okay? The frequency of a wave is the number of wavelengths. That's why we need to learn about the wavelengths, guys, because frequency depends on it. It's the number of wavelengths that passes by a point each second. How many wavelengths do we have? Okay, you'll understand more later. Frequency is related to how rapidly the object or material producing the wave vibrates. So more vibrations means there will be more, how fast the vibrations are means that frequency will change according to this.
Miss, is there homework today?
Yes?
Is there homework?
No, there won't be a homework. I will, guys, upload the study sheets for you to read, inshallah, to read. Okay? So we will do the worksheet next session. Okay?
Okay.
Guys, we have an example, a great example of the frequency and the wavelength. And here we can see the raft. Okay, the girl sitting or the boy sitting on the raft. And here's the wave direction. You can see, of course, the wave direction in there. Okay, and we have here